Hello and welcome to this lesson video where we will learn about the lost hole calculations, namely average hole distance and average hole grade, which are applied to the mass diagram to get useful information needed to estimate the cut to fill operation productivity. This video covers the shown two learning objectives. As a recap, we learned about mass earthwork diagrams and their main benefits or uses as shown. The mass diagrams enable us to calculate the soil cut and fill quantities at different areas of the project, the number and boundaries of the different balanced CTF operations, the appropriate equipment to use for optimal CTF operations, and the type of the project to be either a borrow or waste site in terms of the net moving volume. One last thing we need to learn is to calculate the average hole distances and grades for each equipment used in the CTF operation. So the total hole quantity, Q, is moved in multiple trips between the different spots in the cut area to the different spots in the fill area. In the early planning phases of the project, detailed hole plans are not performed, but the project managers mainly focus on estimating the production rates of the CTF operation. These rates depend on many factors, as we'll see in future lectures. But production rates greatly depend on the hole distance. Now, knowing that every hole trip within the balanced CTF zone has its own hole distance, we will adapt a macro analysis approach for the whole CTF hole operation and find an average holing distance. The average hole distance is a representative distance between the cut and fill areas within a balanced CTF zone, which we get by assuming a uniform cut and fill depths. As you can see here, the cut depth in the shown balanced zone is maximum in the left extreme side, while the maximum fill depth is on the other side of the zone. As such, a lot of hole trips will be related to these two spots. By assuming a uniform cut and fill depths in the cut and fill area, we can calculate a representative holing distance for the whole zone by averaging the number of holing trips and soil moved between the different spots. So the average hole distance of a balanced CTF zone is calculated by dividing the mass diagram area and the whole quantity related to the CTF zone. The mass diagram area is the area contained within the diagram by the balance line or balance lines if we are dealing with compound balanced zones. The whole quantity or total yardage is the mass coordinate contained within between the mass diagram and the balance lines. If we check the units, the mass diagram area has units of distance times soil volumes, while the whole quantity has a volume unit. So dividing these two quantities will give a distance value, which is the average holing distance. This calculation is kind of transforming the mass original diagram of the balanced zone into a rectangular shape with the holing quantity as the height and the average holing distance as the base. This is another example of calculating the average holing distance of scrapers, which work with some dozers on the same big balanced zone. The whole quantity of the scrapers is shown here, and the area under the mass diagram is shown to be confined by the balance lines of the scrapers and the dozers. The average hole grade of slope is another important parameter that affects the earthwork equipment speed, which impacts the production rate of the CTF hauling operation. Similar to the average hauling distance, the hauling grade is averaged over the multiple haul trips within the CTF balanced zone. Each haul trip moves the soil between two different cut and fill spots with varying elevations and haul distances. For the average haul grade, we will need the help of the profile view to find the elevation change between the cut and fill areas of the balanced zone. We find this average elevation change as the difference between the average cut and fill levels, as shown by these two horizontal red lines, DE and FG. Line DE is at the middle of the cut maximum height, and the line FG is at the middle of the fill maximum depth. After we identify this elevation and change value graphically from the profile view, we need to calculate the average haul distance as we covered in the previous slide. So the average haul grade as a percentage value is calculated using the shown value as the percentage ratio between the change in the elevation and the average haul distance. For the shown CTF job, the equipment will experience on average a downhill grade of 5% when moving the soil from the cut to the fill area, and an uphill grade of 5% when returning back empty from the fill to the cut area. Thank you for checking this lecture video. I hope it was helpful and informative. In the next lesson, we'll cover the impact of the haul grade in action when we cover a very important topic, which is machine power. Thank you, and cheers.